Hi, I am Mette Nielsen. I'm an entomologist at Plant and Food Research in Lincoln, and I'm giving this talk today on behalf of my colleague Jessica and also Rob from Berrywell as part of the webinar that we've done for the SFF project Future-Proofing Thrips Management in Strawberries. The talk is meant to give a bit of a quick insight into what integrated pest management or IPM is, what is driving it, and what as growers you can expect and what the system expects from you for this to be a successful venture. So what is integrated pest management? It's a sustainable approach combining biological, cultural, physical, and chemical tools to regulate pest. And by pest, we mean insects and pathogens. As growers, you'll be well aware already of step 1 and 2 in this module that is showing on the screen. But what really comes into it with IPM is all about the observations, actually crop monitoring to know in real time what is going on in regards to your pest pressure. Then also the intervention part of it is quite different from the traditional system, is that you try and start with the least benign. So it could, for example, be a mechanical control, removing some crops. It could be releasing a beneficial as part of the biological controls. And then as a last resort, you might look at some chemical options. Then there's an evaluation process of how well that worked, and then it will constantly feed back to ongoing crop monitoring. Why did integrated pest management come about? The term was really first used in the 1970s, and it was in a growing response to the negative side effect of pesticide overuse that was seen. The approach emphasized the integration of insect and pathogen biology and cultural practices in managing the pests in the crops. New ways of dealing with pests were promoted partly by the withdrawal of many common chemicals that was being used and a general trend in health and safety. What is driving integrated pest management uptake? Today, many countries and its farmers have begun a movement toward decreasing pesticide use. And the decrease in pesticide use is really what is driving it. Health and safety, that we just mentioned that in regards to what really sparked this movement, but approximately 40 different EPA-registered pesticides on the market today are classified as known, probable, and possible human carcinogenic, so those are still very big drivers today. Also, the trend is continued reinforced by frequent media reports where we're finding pesticide residues or their metabolites in, for example, surface water or our food. However, overuse also began showing its negative effect in regards to the lack of control and resistance that the farmers were observing. Today, more than 500 insect and mite species are known to be resistant to at least some of the insecticides that are used for their control. This can in some cases be made quite worse by the insecticide portfolio to combat these pests are gradually decreasing. The trend is not just for insecticides, but also found to be so for herbicides and fungicides. In the last decade, another very strong driver is regulatory measures and consumer trends. A consumer report on pesticide residues found in fruit and veg that came out in 2020 showed that out of the 9 residues found, 7 were either banned in the EU or on the EPA list for being reviewed. That meant that what was currently being used by New Zealand growers would either mean that they would lose market access because it was banned, or they were soon not able to use the current pesticide at all. There are almost 40 chemicals today that are being reviewed by the EPA in the near future, and they may all be restricted or banned in some way. Also, consumers are constantly wanting to see less chemistry being used in food production. This is heavily reflected in the supermarkets and what they will or will not allow in regards to insecticides. Today, the list of unacceptable active ingredients that are being banned by the big brand supermarkets is long, and it's only getting longer each year. By growing within a system like IPM that is less reliant on chemical interventions by the grower, we'll be able to stay ahead of the game and hopefully allow in the future for the growers to see a premium being paid out to anybody who grows, for example, strawberries under a certified IPM program. So it's not all doom and gloom. Some of the drivers are very positive indeed. So a lot of research is carried out today developing advantages that will facilitate better management of pests without relying on pesticide spray. It can be from passive monitoring programs that allow growers to keep a very close eye on their crop to new cultural control techniques, like what's pictured here from Cornwall in the USA, where light is being used to produce pesticide-free strawberry fruit. So it's not just insect that this machine is targeting, but also diseases, and they plan to roll this out across their growers on the East Coast over the next 5 years. These kinds of what we call precision agricultural advantages and machine learning will see a digital transformation of agriculture and horticulture in the future, and that is all very, very good things for IPM. Machine learning or precision agriculture will assist very heavily in precise and real-time monitoring, and this is the bedrock of IPM. So advances in this field will allow growers to be aware of any pest or beneficial or diseases or management changes that will be occurring in their crop. This ensures that the ability to enact countermeasures if, for example, a pest population starts to get too high or beneficial numbers are dropping, can be done. So as an example, if we had this kind of technology done by a drone, it could feed into what they call here a health map in Australia, and it will basically show the grower in real time where his issues are. So the red could, for example, be indicating of thrips numbers that are getting too high, and he will know exactly what part of the crop or his farm is in trouble. Then he can take his actions and say, okay, now what to do. And it could, for example, be using a drone to release beneficials in spots where he knows that they're needed, or it could be he may decide that it's across the board that they need a top-up. Could also be applying a microbial biopesticides, for example, or it could be spot spraying with a selective pesticide. I just want to point out that there's also a big drive in developing new beneficial insects, new biopesticides, so that's both based on microbial, botanical, or semiochemicals, and also new selective insecticides for horticulture and agriculture. There's a huge drive for developing new products in these fields. Even big players like Syngenta today have whole department dedicated to what I would call the softer side of pest management. In regards to the more traditional use chemistry, so what the growers are known to use today, if they stay being available for the growers, the way we use them will most likely change simply because of new technologies also coming on. So one thing is like this: you could, for example, just spot spray and only target it where it's very needed. There are also very much new techniques like this, and these are what we call where they change the delivery system. This is for ants, but it could just as well work for example, thrips. So these are hydrogel capsules that have a controlled bait release. And so the idea is you put them out where they're needed. So let's say you use them for thrips in strawberries. The beets will go out, so there will be no spraying on the fruit. The fruit will be completely unharmed. They could potentially be put on leaves, and the thrips will simply feed through the membrane because the beets will have a semiochemical that will stimulate them to think that this is a plant, and they will take up any kind of selective control measures that way, and lot less risk for the environment, for the human side, and the amount of active ingredients that are being used are very, very low. Better knowledge transfer. I would say strawberry growers of New Zealand have already shown how fantastic a tool this can be, and I think there will be no trouble in this industry to really take advantage of this. We have fantastic growers in the industry that are willing to, tell others about how they've fared with going with IPM and how to learn from them. What can growers expect from an integrated pest management system? It's a gradual transitioning from an unbalanced to a balanced system that is more resilient. So the resilience basically means that if something is to happen, like an incursion, for example, that it can be quickly brought back to a better stage. And the whole idea is that we have the standing army approach. So if you have a crop that is sprayed out and there's nothing in there, if you have an incursion of, for example, thrips because somebody in the neighborhood have cut their lucerne, there will be nothing to combat them when they arrive. But if you have a standing army of predatory mites, for example, then it's ready to go by the time they get there. What does the integrated pest management system need from the grower? So it's a bit of a new mindset in the way insects and diseases are managed. It is not a one-for-one. One spray will not be taken out by one, for example, semiochemical tool. That is just not how that's going to work. Prevention will be better than the cure. Always start with the very best foundation for not having a problem occur later. Attain knowledge to make informed decision and empower. So part of that is certainly the monitoring. It is a continuing, ongoing tool that will be absolutely bedrock for any decisions going forward. Show flexibility. You never know what you're going to get, and you're constantly, as grower, going to have to be vigilant and adapt to whatever is going on in your crop. Embrace the IPM system of inclusion. All management on the table. So it may be a matter of, okay, it's better just to rogue out a few plants or to put in a control because we know the issue is coming, for example, like the lucerne being cut, and we know at this point of time we'll see a migration into the crop, etc. Be a caretaker. These are living organisms being used, so compared to if you're used to only spraying, it will require looking after. If you are releasing mites, for example, in your crop, they will not be happy about you putting on a miticide, most likely. That's going to make it very hard for them. Or if you have very dusty roads, and when the dust settles on the plant, can actually make the mite not flourish because they don't like those kind of conditions. So you need to be a caregiver. Just want to put up this disclaimer and acknowledge that the client for this is Strawberry Growers New Zealand. And funding is sourced by Strawberry Growers New Zealand and also funded by the Sustainable Farming Fund that sits under MPI. Thank you.